A chamfer is a type of feature where an edge or corner is beveled. In Creo parametric, there are two types of chamfers: corner chamfers and edge chamfers. To create an edge chamfer, click on Chamfer in the Engineering tools and select Edge Chamfer. Next, choose multiple edges by selecting the first edge, holding Ctrl and selecting the other edges you want to be chamfered. These four edge chamfers are in the same set, meaning that each of these chamfers will have the same dimensions. The default chamfer selected is d times d, which creates a chamfer at the distance from the edge along each surface. To change the distance, move either these white boxes or insert a specific value. Let's create another chamfer. Click New Set to add a new set of chamfers. This time we'll add material rather than remove it by choosing these edges. This set of chamfers will be a D1 by D2 type chamfer, which creates a chamfer at the distance D1 from the selected edge along one surface and a distance D2 from the selected edge along the other surface. Click OK to finish the feature. A corner chamfer removes material from the corner of a part, creating a beveled surface between the three original surfaces common to the corner. To create a corner chamfer, click on Chamfer in the Engineering tools and select Corner Chamfer. Next, select a vertex that will be the reference of the corner chamfer. Similar to the edge chamfer, to set the distance from the corner, either drag this white box or insert a specific value. Click OK to finish the feature.
Auto round. In this task, we utilize an auto round to create rounds on a complex model. Disable all datum display types. From the Engineering group, click Auto Round from the Rounds Type drop-down menu. Edit the convex radius value to 1 if necessary. Select Same for the concave radius value if necessary. Select the Scope tab and observe the options. Click Complete Feature. The auto round will take a few moments to generate. Select the auto round from the model tree, right-click and select Edit Definition. Select the Exclude tab. Press Ctrl and select 4 edges to exclude. Click Complete Feature. The auto round will take a few moments to generate. Drag the Insert indicator directly before the auto round feature. Select Sketch 1 from the model tree, then click Extrude from the Shapes group. Edit the depth to 15. Click Complete Feature. Right-click the Insert indicator and click Cancel. Click Yes. Notice the auto round has encompassed the inserted feature. Select Auto Round 1 from the model tree. Right-click and select Convert to Group. Click OK. Expand the local group, Group Local _ Group. Right-click the local group and select Ungroup. Notice that the auto round has been converted to a series of standard round features.
Before I start, I'm going to make sure I don't have any other Creo project windows open. Here I have a basic assembly line with various machinery and objects in the environment. I begin by selecting the Manikin tab on my ribbon, then clicking the Insert Manikin button. A dialog box appears. The first reference I select will be where I want my mannequin to stand. This is done by left-clicking in that spot. Here I'm putting my mannequin close to the center of the assembly line floor. The next reference I select will dictate which way my mannequin will face. This is also done by left-clicking. As you can see, the mannequin faces whatever surface I select as my second reference. I'm going to accept the mannequin's current position by clicking OK. If I don't like where my mannequin is standing or facing, I can go back and edit my references by first selecting the mannequin in the model tree, then going up to the Manikin tab and selecting Edit Placement. Here I'm selecting the reference that I'd like to change, as well as the face that will be the new reference. In the initial dialog box, there are two basic postures I can choose from, standing and sitting. I've already touched on standing, so now I'm going to take a look at the sitting functionality. First, I'm going to import another mannequin into the model tree, but this time I'm going to check the option labeled Sitting in the dialog box. If I select the bottom face of the chair next to the assembly line, the mannequin will now be in a seated position adjacent to the chair. As with the standing mannequin, the next reference I select will be which way I'd like the mannequin to face. Here I will select the wall behind the mannequin. This will result in the mannequin facing that wall. To turn the mannequin around, I'm going to click the flip option to the right of the Select Reference To button. My mannequin should now be in a sitting position on the chair and facing forward. Mannequins are useful tools for assessing the size and scale of an object in Creo. They include more complex functionality than
Creo Parametric provides you with many options to control the display of your models, making them easier to view and work with. When you open a model in Creo Parametric for the first time, you should notice several changes in the display of your model. The first change you may notice is that the display of name tags for all datum features, other than the coordinate system, have been turned off. This cleaner look keeps your model's display less cluttered, making it easier to work with. You can find the name of any feature by moving your cursor over it, and when the feature pre-highlights, its name will be displayed. To turn the display of datum tags back on, go to the View tab, and in the Show Group, you can toggle the display on and off. You should also notice that new lighting has been applied to your models. New solid features will default to this medium gray color that contains lower shine and reflection than previous releases. Creo Parametric includes a new model display type called Shade with Edges. When this display is activated from the graphics toolbar, all model edges are displayed in black, making the details of your model easier to see and work with. If a solid extrusion is edited to be a surface feature, you'll see that it changes from the gray to a blue-violet color that contains higher shine and reflection. This is true for all surface features in Creo Parametric. To permanently change the display of either datum tags or the model's display type, click File Options, then click on Entity Display. If you change the display settings here and click OK, you'll be prompted to save the setting to a configuration file. If you save these settings, Creo Parametric will apply them the next time it's started. Note that Creo Parametric includes even more graphic enhancements than we've seen here. Feel free to explore. In Creo Parametric, you can add edge, surface, and sketched rips to your sheet metal models to help flatten otherwise unbendable geometry. You can see that creating a flat pattern of this model in sheet metal will require that some of the sheet metal surfaces be either removed or ripped. You will first use the Surface Rip tool to remove the outer corners of the model. Next, create the edge rips between the corners. This will enable the top surface to unfold about the edge that has not been ripped. Now you will sketch a rip on this wall so that the vertical walls can be unfolded. Let's orient our model so we can sketch a little easier and draw the line that defines the rip. Now that the rips have been applied to the model, it easily unbends. Whether your design is simple or complex, Creo Parametric's intuitive rip tools make it easier to ensure your sheet metal models are manufacturable. In Creo Parametric, you can add flexibility to any component that has already been placed in an assembly. Many designs contain flexible components, such as springs, clips, rubber washers, and so on. In this assembly, we have a plastic water nozzle traveling through a flexible foam housing, and then the flexible upper foam housing fits over both, fitting snugly to the lower housing. However, we can see from this cross-section view that there is interference when the components are assembled. There's interference between the nozzle and the lower housing, and the lower and upper housing. To add flexibility to the lower housing, select it, right-click, and select Make Flexible from the pop-up menu. Select the hole at the center of the housing, which we're going to want to expand in the assembled condition so that the nozzle can fit through it. Select the hole's diameter and then add it to the varied dimensions list. The current diameter of the hole is 12, but we'll enter a new flexible diameter of 14 and then click OK. Notice that the nozzle no longer interferes with the flexible lower housing, and that a new flexible icon has been added next to the flexible component in the model tree. The next interference to address is between the upper and lower housing. When assembled, the upper housing should flex over the lower housing. To fix the interference, right-click the upper housing and select Make Flexible. Select the Interior Extrude feature and add this thickness dimension to the Variable Dimensions list. Because we want to show how to go back and edit these values after completing the operation, in this example we're going to set the assembled value to be 9, even though we know that we actually want the thickness to decrease in the assembled condition. A quick look at the cross-section makes it clear that we flexed the upper housing in the wrong direction, but it's easy to fix. Just edit the definition of the upper housing. In the dashboard, open the Flexibility tab and select Varied Items. Edit the flexible value back to 7 and complete the operation. There. Now the interference between the components has been completely removed. Even if your assembled components don't have any predefined flexibility, Creo Parametric makes it easy to add it on the fly, making adjustments later in the design process quick and painless. Did you know that sheet metal models can be formed using punches in Creo Parametric? A form is a shape in your sheet metal part that is molded by another part. A form feature is created by merging the geometry of a reference part to the sheet metal part. To place a punch form feature, click Punch Form from the Form Type drop-down menu in the Engineering group. In the dashboard, click Open so that you can select the part that will be used as the tool to create the form. In this case, select the louver form part. A form part is positioned on the sheet metal part using either assembly constraints or an on-surface coordinate system. This louver form part uses an on-surface coordinate system for its placement. Query to place this form on the inside surface of the sheet metal part. Then use the green offset reference drag handles to position the part on that surface. If you need to rotate the form, open the Placement tab and enable Add Rotation about the first axis. Since we're making a louver, we want a surface to be left open. So open the Options tab and activate the Excluded Punch Model Surfaces collector. Then select this surface to be excluded. Before completing the feature, notice that this form is being placed using the Dependent Merge option. This means that in order to change the shape of the form, you'll need to change the louver form part model. If you needed or wanted to edit the sheet metal part independently from the form, it can be placed using the Independent Inheritance option, which would add the features and dimensions of the form part to the sheet metal part. After completing the feature, you can see in the model tree that the features of the form have been added to the sheet metal part. Let's start the Punch Form tool again, and this time we'll place a form named Gusset Form using assembly constraints that are predefined in the form as a component interface. To position this form part, select this surface, the top surface, and this surface as an offset reference. Preview the feature and notice that there are no rounds where the form meets the sheet metal. Open the Options tab and enable Placement Edges. Then preview the feature again and notice that rounds have been added. Also notice that this form is going to be placed using the Dependent Merge option. This means that in the model tree we won't see features that make the form. To edit this feature, the Gusset Form part would have to be edited. Creo Parametric makes it easy to more accurately simulate your manufacturing process with flexible punch forms that can be added to your sheet metal models.